This is the story of Mohawk Airlines Flight 40. On the 23rd of June 1967, a BAC 111 was flying from Syracuse to Washington, D.C., with a stopover in Elmira, New York. The BAC 111 that they were flying that day was brand new, having only had its first flight the year before. Also, do you think that BAC should have called the 111 the 111? You know, like how we say 777 today? I think the 111 sounds a lot better. By 2:07 p.m. local time, the plane was at Elmira. At Elmira, a few people got off, a few people got on, bringing the total number of passengers on the flight to 30. As soon as everyone was on board, Flight 40 got its IFR, or Instrument Flight Rules clearance, to Washington. Their clearance only allowed them to climb to 6,000 feet instead of the requested 16,000 feet, as there was conflicting traffic in the area. The plane took off from Elmira at 2:39 p.m., and the controllers watched the plane as it took off, and it turned left towards the south. Soon after takeoff, the plane was handed off to the New York Center, and the plane continued to climb. At 2:24 p.m., New York Center cleared the plane to climb and maintain 16,000 feet. The controller at New York listened for their acknowledgement, but nothing. Flight 40 was not responding. The controller turned to its radar scope. The radar screen updated every 12 seconds or one sweep. At first, the plane appeared to slow down, and then it moved laterally during the next sweep. In the air, as the New York Center cleared them to climb, the first officer remarked, "It's hard to tell just what it is. Something was not going according to plan." They pulled their speed back. For some reason, they were having control problems. The first officer said, "There's something screwy here." The pilots decided to return to Elmira, but their transmissions weren't getting through. No one on the ground knew that Flight 40 was in trouble. In the cockpit, the captain exclaimed, "We've lost all control. We don't have anything." They struggled to turn their plane back towards Elmira. By 2:46 p.m., the captain was no longer trying to turn the plane back towards the airport. He was just trying to keep it level. He then asked his first officer, "What have we done to that tail surface? You have any idea?" To which the first officer replied with, "I don't know. I just can't figure it out." But their attempts were in vain. The plane started to dive, and the speed of the plane increased from 224 knots to 315 knots. In the cockpit, the captain said, "I've gone out of control." That was the last thing recorded on the cockpit voice recorder. At New York Center, by the third sweep of the radar screen, the blip that represented Flight 40 was nowhere to be found. ATC rerouted a Piper Aztec to the last known position of Flight 40. The pilot of the Aztec radioed in a burning wreck of a plane. It was Flight 40. Unfortunately, none of the 34 people on board survived. People in the town of Mansfield, Pennsylvania, saw the plane go down. Those eyewitness testimonies gave the investigators the first clues to unlocking what happened to Flight 40. They saw a plane that was flying lower than other planes in the area. At first, it was flying level, but then they saw smoke coming out of the plane from the back. The witnesses could not agree on the color of the smoke. Some said it was gray, some said it was black, and some said that it was a brown, almost rust-colored. But the eyewitness testimonies pointed to one culprit: an in-flight fire. A look at the wreckage corroborated what the eyewitnesses had said. Molten metal was splattered on the vertical tail fin. This proved that there was an in-flight fire, as you needed airflow over the fin for molten metal to be spread like that. The soot marks also proved that the fire was active when air was passing over the flames. The damaged husk of the plane allowed them to pinpoint the exact source of the fire. It was at the back of the plane, specifically near the APU. The APU, or the Auxiliary Power Unit, is basically a small jet engine that powers the plane. In flight, most of the electrical power that the plane needs is generated by the engines. But when you're on the ground, you can't keep your engines running all the time. Think of when a plane's at the gate. You can't have powerful jet engines running when bags are being loaded and people are getting on the plane. In those cases, you can either get power from a ground power unit or you can use the APU. This is where they focused their investigation. The metal there had melted away. This meant that the fire had burned hot. They were able to estimate that the fire had to reach temperatures near 648 degrees Celsius or 882 degrees Fahrenheit. No wonder the airframe melted away. Now that the fire and its position had been confirmed, they needed to figure out what caused the fire. They were looking for two things: something that could burn and something that could start the fire. The obvious culprit was a fuel leak. So they took an identical plane and used colored water to see where fuel would pool if there were to be a leak in the fuel pipes at the back of the plane. In none of those tests did the simulated fuel reach where the fire was. They also looked at the possibility of reverse thrust exhaust. Reverse thrust exhaust increased the temperatures at the back near the APU by 8 degrees Celsius or 46 degrees Fahrenheit, not enough for anything to catch fire back there. They then tried to see if hydraulic fluid could make it into the plenum chamber or the pressurized chamber where the APU was. Most of the hydraulic fluid drained away, but the seal between the hydraulic fluid compensator bay and the plenum chamber was flawed, allowing fluid to leak in bit by bit. This hydraulic fluid would then get absorbed by the acoustic lining in the plenum chamber. But this theory had a problem. Sure, hydraulic fluid can be flammable if it's really hot. Sure, the soft lining drenched in hydraulic fluid can go up in flames, but they still did not have an ignition source. The chamber never got hot enough for this mixture to combust. They did tests to see if the lining would catch fire due to them rubbing up against each other due to the noise and vibrations. They subjected it to vibrations well beyond anything they'd encounter in flight. It got hot, but not hot enough to burn. They decided to test another theory. The BAC-111 has what's known as a pneumatic system. The pneumatic system basically uses hot, high-pressure air from the engines. In the Lufthansa 540 video, we talked about how early 747s used pneumatics for its flap system. In a pneumatic system on an airplane, you tap some high-pressure air from the engine compressor. This is known as bleed air, and you can use this air for anything from de-icing the plane to running the air conditioners. The APU could also power the pneumatic system on the BAC-111. You could either use bleed air from the engines or the bleed air from the APU. They wondered, what if somehow the bleed air from the engines got into the plenum chamber where the APU was situated? In normal operations, this is not supposed to happen as the APU has a non-return valve. The non-return valve makes it so that the APU can send air into the pneumatic system, but the bleed air from the engines would not reach the APU. The valve would prevent that. To test all of this out, they built a mock-up of the backside of the plane, and they got a high-pressure hot air source to act as the engine, and they set temperature sensors all around the APU to see what would happen. When the non-return valve was opened on the test stand, the bleed air from the simulated engine pushed up against the air being sent by the APU. Eventually, the hot air from the engine overpowered the APU. The APU sputtered for a bit, but it kept working. But this time, air was flowing in reverse through the APU. But, more interestingly, a lot of this hot, high-pressure air was making its way into the plenum chamber where the APU was situated. The temperature sensors in the chamber were recording insane temperatures. The chamber was at 375 degrees Celsius or 707 degrees Fahrenheit. In some tests, the acoustic lining trapped heat in the chamber, and so it reached 515 degrees Celsius or 960 degrees Fahrenheit. This chamber is supposed to be at 70 degrees Celsius or 158 degrees Fahrenheit during normal operation. This test showed that if bleed air from the engine bled into the plenum chamber, it could raise temperatures a lot. At the end of the tests, here's what they found. Quote, in addition, there was evidence that internal combustion had occurred within some of the linings, primarily in localized areas. End quote. For context, let's look at the properties of Skydrol, the hydraulic fluid that was used on the plane. Skydrol is a fire-resistant hydraulic fluid. This meant that its autogenous ignition temperature, or the lowest temperature at which it spontaneously combusts, is 399 degrees Celsius or 750 degrees Fahrenheit. With bleed air from the engines and the acoustic lining trapping all that heat, it is possible that a fire could have started there. In fact, when they looked at acoustic linings from other planes, some of them showed signs of heat damage. Now, the question becomes, how could this happen? Looking at the wreck, they found that the non-return valve that protected the APU from the hot bleed air from the engine was partially open. This was not an isolated incident. Other non-return valves from other planes also showed signs of damage. The non-return valve had two flaps inside it that prevented air from passing. When you opened or closed it, the flaps would snap open or snap shut, so they'd bump up against the stops. And on particularly short flights, the non-return valve was used very rapidly. Investigators think that this rapid use is what led to the valve failing. There were subtle warnings. There were a few write-ups in the maintenance logs about the APU. Sometimes they'd hear a sound at the back when they used the non-return valve. Some people saw a thin mist at the back of the plane, and on the morning of the accident, there was a burnt smell at the back of the plane, but no one traced it to the broken non-return valve. On that fateful day, unknown to the pilots, the acoustic linings were soaked with a little bit of hydraulic fluid due to the imperfect seal that we talked about before. The failed non-return valve sent hot air into the plenum chamber, raising temperatures sky high. Before long, one small part of the lining ignited, which ignited another part, and before you know it, you had a fire. The fire burnt hot, and eventually it burned through everything at the back, including the hydraulic lines, which just made the fire worse. This robbed the pilots of their ability to control the plane, as their plane melted at the back. At this point, the pilots were just as much a passenger as anyone else on the plane. The really interesting part about this crash is that we're able to pinpoint the source of the fire, and we were able to act on it. In so many cases of in-flight fires, we're not able to figure out what happened as the fire consumes what started it. If you know of any such unsolved mysteries in the air, do let me know in the comments below. Also, do you think that Flight 40 would have been able to make it back had there been a heat sensor in the back or something? I'd love to hear your thoughts. Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I will catch you guys next time. Stay safe.